students. Hi students, now we are discussing worksheet 3 related to reflexive symmetric transitive properties of a relation. Here in a problem they will be given one set and one relation. Now this relation is defined on this set. Now we have to check it whether this relation reflexive or not, symmetric or not, transitive or not. If any relation which satisfies these three properties, that is called equivalence relation. So we must have the two tools, then only we can check these. Enter tools, reflexive definition, symmetric definition, transitive definition. Do you know reflexive definition? Tell me. For all elements in A means, here A means, small a means element in a set A. Any element you can take in set A, that element is related to itself. A related to A. This is the notation. Or we can write like this, A comma A belongs to R. We can write like this also. What is the meaning of it? It is the first coordinate and it is the second coordinate. Between these coordinates, one relation exists, that is the given relation. What is given here is perpendicular. So what is the set? Straight lines in a plane. So what is the first task to decide it? In any problem, what is the set is given and what is the relation is given. Now we have to check that relation is satisfies these properties on that set or not. We have to check it. So for reflexive we will take only single element. That relation also must be itself. అందుకే ఏంటంటే ఈ సెట్లో ఎన్ని ఎలిమెంట్స్ ఉన్నాయి నాన్న? సపోజ్ ఎన్ ఎలిమెంట్స్ ఉన్నాయి అనుకుందాం. ఏంటి ఎన్ ఎలిమెంట్స్? ఎన్ స్ట్రైట్ లైన్స్. ఓకే, L1 L2 L3 so on. Is every line is perpendicular to itself? No, every line is not a perpendicular to itself. No, every line is parallel to itself. Okay, because coincident lines are also parallel. So that's why every line is not a perpendicular to itself. So that's why it is not a reflexive. R is not a reflexive. Is it symmetric or not? Check it. For symmetric, what we have to do it? We have to take one ordered pair in R. One ordered pair in R, L1 comma L2 in R. Now you have to prove it. L2 comma L1 is in R or not? We have to prove it. Ordered pair L2 comma L1 is in R or not? We have to prove it. Okay, what is the meaning of it? If L1 comma L2 is in R means you must take two lines which are perpendicular to each other. Now L1 is perpendicular to L2. Is L2 is perpendicular to L1? Definitely. Okay, L1 line it is, L2 line it is. What is meant by perpendicular? Between angle 90 degrees. So L2 also 90 degrees with L1. No? So that's why definitely it is symmetric. Is it transitive? What is the definition of transitive? Do you know? Transitive means here we must have the three elements. We must take three elements in a set, L1, L2, L3. L1, L2, L3 are any three sets, any three elements in a set A. Here what is the set? Set of straight lines. Set is called set of straight lines. Now these are the elements in set. Now we have to take two ordered pairs. We must take it. What is the definition? L1, L2 is in R, L2, L3 is in R. We have to check it whether L1 comma L3 is in R or not. We have to check it. మనం కనుక్కోవాలి ఇది. So what is the meaning of L1 comma L2 belongs to R? The meaning of it is take a one line L1. It is L1 is perpendicular to L2. Now you take one more. You take a one more line. L3 you take it. So second order pair is L2 comma L3 also is in R. What is the meaning of it? L2 is perpendicular to L3. Like this we can take it and it is possible. Now observe L1 and L3. Are both perpendicular? No, both are parallel. These are not a perpendicular. So that's why L1 comma L3 is not in R. Therefore, what do we notice from this? It is not a symmetric. So it is only transitive. So first answer is the correct answer. Shall we go next problem? So this is the second problem. Observe here. First we have to check for equivalence, whatever it may be. We have to check it. What is the given set and what is the given relation? Here set is A. A contains 3 elements and set relation R is given 2 ordered pairs. 1, 2, 2, 3. Now what is the question asking? The minimum number of ordered pairs which when added to R. Minimum number of ordered pairs to add R, make it a equivalence relation. To get a equivalence relation. What is the definition of equivalence relation? It must satisfy reflexive, symmetric, transitive, then it is called equivalence relation. For equivalence relation, first reflexive means, for reflexive, what are the ordered pairs must be here? Here ordered pairs are, what is reflexive? Every element is related to itself, no? So that's why here you must take it, 1 comma 1 must be in R, and 2 comma 2 must be in R, and 3 comma 3 also must be in R. Minimum these 3 ordered pairs must be in, then only we'll get, then only this is called reflexive relation. Reflexive relation అంటే ఏంటి తెలుసు కదా, ఏలో ఉన్న ప్రతి ఎలిమెంట్కి ఇట్ సెల్ఫ్ రిలేషన్ కావాలి. మీన్స్ 1 comma 1 must be in R, 2 comma 2, 3 comma 3. 3 ordered pairs we got it. For symmetric, we must have 1 comma 2 is in R, then definitely 2 comma 1 also must be in R. Then only it is symmetric. Very good. And again 2 comma 3 is there, no? 2 comma 3 is in R. We must contains 3 comma 2 also must be in R. 3 comma 2 also must be in R. Clear? So now here we have the 3 ordered pairs. Here we have the 3 ordered pairs. Here 2 ordered pairs. Total we have 5 ordered pairs. Now we have to check one more. That is called transitive relation. For transitive relation, what must be? Observe here. 1 comma 2 in R. 2 comma 3 in R. What must be? 1 comma 3 also must be in R. So 1 comma 3 must be in R. So that's why here 1 comma 3 also not there, no, in R. So that's why we must take it 1 comma 3 also must be in R. If 1 comma 3 is in R, definitely 3 comma 1 also must be. Then only that is symmetric. Okay, so total how many ordered pairs we got? 1, 2, 3, 4, 5, 6, 7. So your answer is 7. Thank you.